we had studied about the consistency of the equation. So I'll show you. I had discussed this 𝐒𝐤𝐤𝐤𝐿 example in the first class, and I was also discussed how we frame the situation algebraically. That means how we put this in the form of linear equation in two variables. Now also we had learned about the solution of the equation. We had learned about the geometric meaning of solution of the equation, and something very important that we discussed about the consistency of the equation. That means whether the solution exists or doesn't exist. So there are two ways of finding the consistency of the equation. The first way is the graphical method, where we see whether the lines are intersecting or they are parallel or they are overlapping lines. That means the coincident lines. And another way is algebraic method. Algebraic method, that means we compare the ratios A1 upon A2, B1 upon B2. I'll show you this. Give me a minute. So here we have algebraic method. This one we discussed in the previous class. So in algebraic method of checking whether the set of equations is consistent or not, we compare A1 upon A2, B1 upon B2 and C1 upon C2 like this. Now here, if A1 upon A2 is not equal to B1 upon B2, we say that the set of equations is consistent. Consistent means it has solution. There is unique solution. There is unique solution for this. Unique solution means that the lines representing these two equations would be intersecting lines. Now, if we have A1 upon A2 equal to B1 upon B2 equal to C1 upon C2, then the set of equations is again consistent. Yes, we have solution, but in this case, we have infinite solutions. Infinite solutions means that these two lines, the lines representing these two equations would be coincident lines. They would be completely overlapping each other. Now comes the third case where A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. This is the case of inconsistency. Inconsistency means that there is no solution. No solution, the set of equations is inconsistent. There is no solution, that means there is no point in common here. So the lines here are parallel lines. They are parallel lines. Now now we've discussed these questions also where we check the consistency of the equations. We check the consistency of the equations by comparing the ratios A1 upon A2, B1 upon B2 and C1 upon C2. Now, also we had discussed in the previous class, I just introduced the substitution method for you. So, we have different ways of solving pair of linear equations in two variables. One is the graphical method. That means we draw graph of both the equations on a single Cartesian plane, and wherever the graphs are meeting, that means the lines are intersecting, that point of intersection is solution of both the equations. So this we discussed in the very first class. Then is the substitution method. These are the algebraic methods which I've listed here. The first one is substitution method, which I had just introduced in the previous class. So we discussed two questions of the same. I'm going to discuss one more question with you all. In fact, we'll do all the NCERT questions here for substitution method. So I'm explaining you again using this particular question. That is 0.2x plus 0.3y equal to 1.3. This is one equation, and another equation is 0.4x plus 0.5y equal to 2.3. Now these are two equations which we have. We need to solve for those values of x and y which satisfies both the equations simultaneously. Now we are going to solve this using substitution method, the same method which I discussed in the previous class. But before we start with anything else, we are going to get rid of these decimal points because it's difficult to work with decimals or even the denominators if we have. So we are going to first simplify this. So I'm going to take the first equation. I can write the 0.2 as 2 upon 10. So this is 2 upon 10x. This is 3 upon 10y. And this is 13 upon 10. Now we can see here the denominators are same. So we can write this as 2x plus 3y over 10 is equal to 13 upon 10. We can cancel out these denominators and then we will get 2x plus 3y is equal to 13. So this is the simplified form for the first equation. I have written this first equation in this form. Let's name this as equation 3. So instead of now using the first equation, I'll be using the third equation. We'll be doing the same with the second equation. So I'll simplify this second equation also. 0.4 we can write as 4 upon 10. 0.5 can be written as 5 upon 10. And then 2.3 we have, this can be written as 23 upon 10. Now these denominators are same. So we'll take the LCM here, that's 10. So we'll take here 4x plus 5y upon 10 equal to 23 upon 10. I'm going to cancel out these two, and then we have 4x plus 5y is equal to 23. That is the fourth equation. Now instead of the second equation, we'll be using the fourth equation. So we have done the simplification part. I've got rid of the decimal point. I've got rid of the denominators also. Now we'll be dealing with these two equations. So I'm writing this again. This is the third equation and this is the fourth one. From here we are going to solve for x and y. Now as discussed in the previous class, we are going to use substitution method. We will take any one of the equations here, either equation 3 or 4, and we'll pick up any one of the variables. We'll write one variable in terms of the other one. So I'm taking now equation 3, and here I'm writing y in terms of x. So what I'm doing here, I'm taking this 2x on the other side. So this will become 3y is equal to 13 minus 2x. Now I can take this 3 on the other side and I will get y as 13 minus 2x over 3. Now this value of y I'm going to pick up and put it in the fourth equation. Please notice, not in the third one. I'm going to put this in the fourth equation. So I'll replace y by 13 minus 2x over 3. So in the next step, I'm writing the fourth equation, that is 4x plus 5y is equal to 23. So I've just written the fourth equation and I'm replacing now this y. So we have 4x plus 5 times of 13 minus 2x over 3 equal to 23. So that's how I've written y in terms of x, and I'm going to pick up this value and I'll put it here. Now let's proceed. We have here 4x plus 65 minus 10x over 3 is equal to 23. I've taken this 5 inside and then I've multiplied. So it's 5 into 13, that is 65. 5 into minus 2x, that's minus 10x. In the next step, I'm going to take the LCM. So as we can see here, LCM is 3. So if LCM is 3, we'll multiply this. We'll get here 12x plus 65 minus 10x is equal to 23. In the next step, I'll take this 3 on the other side and I will multiply this by 23. Also, please observe this 12x and minus 10x. They are like terms. So we can write 12x minus 10x as 2x. And plus 65 I'm writing as it is. 23 into 3 will give us 69. Now I'm going to take this 65 on the other side. This will become negative. 69 minus 65. And now here we have 2x is equal to 4. Finally, we have x is equal to 2. We've got value of one of the variables, x is equal to 2. I can take this value of x is equal to 2 and I can put it in any of the equations here. We can put it in this one or this. Wherever we put, in any case, we are going to get the same result. So I'm going to put x is equal to 2 here. So we have y is equal to 13 minus 2x upon 3. I will now replace x by 2. So I will get 13 minus 2 into 2 upon 3. That is 13 minus 4 upon 3. So we have y is equal to 9 upon 3. Finally, we are going to get y as 3. From here, we will get y is equal to 3. Thus, we've got both the values. We have got x is equal to 2 and y is equal to 3. Now, I'm just explaining you, I'm giving you overview of this question again. We are going to first take the first equation and we'll get rid of the decimal points because it's difficult for us to work with decimal points. Also, we've got denominators here. We'll get rid of the denominators also and we'll bring it down to this equation. We'll do the same with the second equation. We will write 0.4 as 4 upon 10, 0.5 as 5 upon 10 and 2.3 as 23 upon 10. We will also get rid of the denominators. We can cancel out 10 and then we'll be left with this equation. Now these two equations we are going to work with as usual. Here we are using the substitution method. So we'll pick up any one of these equations, either equation 3 or 4. So here I've used equation 3. Equation 3 I've written here y in terms of x. You can also write x in terms of y. In any case you will get the same answer. Whatever you find convenient you can do that. So I have here written y in terms of x. Now once we write this, we are going to pick up this value and we'll put this in the fourth equation. If you have written y in terms of x from equation 3, you will put the value in 4. If you have written y in terms of x or x in terms of y, whatever the case is, from equation 4 you have written, you will put it in the other one, that's equation 3. So here we have got the value of y. We'll put this value in the fourth equation because this one we got from the third equation. Now we'll simplify this. Once this is simplified, we have actually brought this down to a linear equation in one variable and which we know how to solve. We've already studied this in grade 7 and 8. Now we've got a linear equation in one variables and we've solved this. We've got x is equal to 2. So now we know x equal to 2. So we can just take this value of x equal to 2 and we can put in any of these equations. In any case, we will get the same result. So whatever you're finding the easiest, you can put the value there. So you can put here x is equal to 2. Now by putting x is equal to 2 here, we have solved this and we've got y as 3. So thus the required solution is x equal to 2 and y equal to 3. That means x equal to 2 and y equal to 3 are those values of x and y which are going to satisfy both the equations simultaneously. I hope you've all understood this, children. Now let's solve the next one. So we have this equation. Here also we are going to use the substitution method. So the first step here is we will get rid of the denominators since it is difficult to work with the denominators. So just see. Let's name this as equation 2 and this one as this as equation 1 and this as 2. We can see in equation 1 the LCM is 6. So we are going to take the LCM as 6 here. So we will get 9x minus 10y is equal to minus 2. We've taken the LCM here. Now 6 I'm going to take on the other side and it will get multiplied with minus 2. We will get 9x minus 10y is equal to minus 12. Now we cannot simplify this further. We will leave it for the time being. We'll just leave it here. Now coming to the second equation, here also we try to get rid of the denominators. So we have 3, 2 and 6 here. We can see that the LCM here in the LHS is 6. So from second equation, we can write this as 2x plus 3y over 6 is equal to 13 upon 6. We can cancel out 6 here and then we will get here 2x plus 3y is equal to 13. Let's name this as the fourth equation. This is the fourth equation we have. Now instead of first and second equation, we'll be using third and the fourth equation respectively, since these are the simplified forms of first and second equation. So I'll now take this third equation and this is the fourth one. Now we solve this by substitution method. So I'm going to take this third equation and I will write x in terms of y here. So we can write this as 9x is equal to minus 12 plus 10y. Please notice we've taken this minus 10y on the right hand side and this has become plus 10y. Now 9 I'm going to take here. I'll get x equal to minus 12 plus 10y over 9. Now this value of x we are going to put in the fourth equation here. We are going to put it here. So the fourth equation here is 2x plus 3y is equal to 13. So I've just written the fourth equation here. And now I'm going to put this here. It's 2 times of minus 12 plus 10y over 9 plus 3y is equal to 13. So I have taken this value and I've put it here. Now let us solve this. We will get here minus 24. So I'm taking this 2 inside and I'm multiplying. We'll get minus 24 plus 20y over 9 plus 3y is equal to 13. Now in the next step, we will take the LCM. So LCM here is 9. We will get minus 24 plus 20y plus 27y. So I'm multiplying this by 9. Also, I'll multiply this by 9. Basically, I'm multiplying both LHS and RHS by 9. So if I multiply this by 9, 9 in the numerator and denominator will get cancelled. Then we'll get 9 into 3y as 27y and 9 into 13 is 117. Now we are going to simplify this. We can combine these two. They're like terms. We'll get here 47y. And this 24, minus 24, we will take on the right hand side. It will become plus 24. So this is 47y is equal to 117 plus 24. This is going to be 141. 141. Now from here we can see that y is 141 over 47. So let's see. This is how much? This would be 3. So we've got the value of y as 3. We've got one of the variables here, y is equal to 3. So we're going to take this value of y and we'll put it in, let's say, I'm going to put it here in this equation. This is the fourth equation. So put y is equal to 3 in the fourth equation. So we will get 2x plus 3 times of 3 is equal to 13. That is 2x plus 9. This 3 times of 3 is 9. 9 will take on the other side. It will get subtracted. So we will get here, then 2x equal to 13 minus 9. Finally, 2x is 4. So now x is 2. So we have the required solutions here. X is equal to 2 and y equal to 3. I hope students this question is clear to you. Now let us proceed. Now in this question, we have to solve this equation 2x plus 3y equal to 11 and 2x minus 4y equal to minus 24. The first step is we have to solve these two equations. Once we solve these two equations, that means we get the values of x and y. After that, we are going to find the value of m, for which y is equal to mx plus 3. Y equal to mx plus 3. So let us first do the first part here. We have 2x plus 3y is equal to 11. Let's name this as the first equation. Then we have 2x minus 4y equal to minus 24. That's the second equation. Now we'll solve these two equations using substitution method. So today we are going to only learn substitution method. Now let's take here the first equation. I'm writing here y in terms of x. So I'll take this 2x on the other side. I'll get 3y equal to 11 minus 2x. Now this 3 we can take on the other side. It will get divided. So we'll get y equal to 11 minus 2x over 3. This is the value of y we've got in terms of x. Now we will put this third equation, that means this value of y, in the second one. We have got this value of y in terms of x from the first equation. We'll put this in the second one, in the other one. So we will get 2x minus 4 times of 11 minus 2x over 3 equal to minus 24. After this, we'll take this 4, we'll take this 4 inside, or what we can do, we can just straight away take the LCM. As we can see that the LCM here is 3. So I'll multiply throughout by 3. So I'll get here 6x minus 4 times of 11 minus 2x equal to minus 24 into 3 would be minus 72. So I have multiplied both LHS and RHS by 3. So 3 multiplied by 2x is 6x. When I multiply this by 3, this 3 in the numerator and denominator will get cancelled. And this by 3 will get minus 72. So here we have 6x minus 44 plus 8x is equal to minus 72. Let us combine these two. We will get here 14x minus 44. I'm going to take here, I'll get minus 72 plus 44. Minus 72 plus 44. From this, we are going to get minus 72 plus 44 will give us minus 28. So x here is minus 28 over 14. That means x here is minus 2. Now we've got x as minus 2. We are going to take this value and we'll put it here in the third equation. We can put it in first and second also. That's our choice. So here I am putting this in the third equation. So third equation is y is equal to 11 minus 2x over 3. We have got the value of y as minus 2. So here we have upon 3. So y is equal to 11 plus 4 upon 3. That is actually 15. 15 over 3. So y is 5. Now we have got x as minus 2 and y as 5. We have got solution of the given set of equations. Now once this is done, we are going to solve for y is equal to mx plus 3. We will solve for y is equal to mx plus 3. That means we will solve for m here. So y we know is 5. X we have got minus 2. And this 3 I am writing as it is. So this is 5 is equal to minus 2m plus 3. 3 we can take on the other side. We will get 5 minus 3 is equal to minus 2m. That is 2 is equal to minus 2m. And finally, the required value of m is negative 1. Required value of m is negative 1. Okay, children, I hope you've all understood this. Now let us discuss the next question. Just give me 2 minutes. So we have discussed a lot of questions of substitution method today. I'm now starting with the word problems of substitution method. This one. Okay. Now here, I hope you can all see my screen. You can all see the PPT. Form the pair of linear equations for the following problems and find their solution by substitution method. So we have word problems here and we have to first of all form linear equations from them and then we have to solve them, and specifically by substitution method. It is already mentioned here in the question. Now here in the first one, in the first problem we have the difference between two numbers is 26 and one number is 3 times the other. Find them. The difference between two numbers. We have two numbers here. They are unknown quantities. Let us take the numbers as x and y. So let the numbers be x and y. Now the difference between two numbers is 26. So let us take the bigger number as x and the smaller one as y. So I have already mentioned here y greater than x. So y is the bigger one, x is the smaller one. I know that the difference between two numbers is 26. That means the bigger one minus the smaller one is 26. That's the first equation which we have got. Also, it is given one number is 3 times the other. So the bigger one would obviously be 3 times the smaller one. You cannot have the smaller one as 3 times the bigger one. Not possible. So bigger number y is 3 times the smaller one. That's 3x. So it's very simple. We have got these two equations here and we have to solve them using substitution method. Please notice here in this one, in the second equation, y is already given in terms of x. So we have saved our effort here. Y is already given in terms of x. We can just put this value of y in the first one. So we are going to put y is equal to 3x in the first equation. So we'll replace this and we'll get 3x minus x is equal to 26. That is actually 2x equal to 26. Finally, we've got x as 13. 26 over 2, that's 13. Now x is 13. We'll pick up this value and we're going to put it in the second equation. So put x is equal to 13 in the second equation, and then we will get here y is equal to 3x. That's the second equation. So y is 3 times of 13. So y finally is 39. We've got the bigger number as 39 and the smaller one as 13. So just for checking this, you can also just observe that the difference between the two numbers is 26. This was given to us in the question. So x is 13 and y is 39. We can see that here the difference between these two numbers is 26. So one condition is satisfied. Also, it was given to us that one number is 3 times the other. So we can see here we have the bigger number as 39 and the smaller one as 13. So 39 is 3 times of 13. I hope you all know the table of 13. 13 3s are 39. So 39 is 3 times of 13. So this is just for checking that just check whether both the conditions here are satisfied according to the questions. So once you're done with this, please do not forget to write the concluding statement. You can just write thus the required numbers are 13 and 39. That was very simple. So let's proceed now. In the next problem, it's given to us the larger of two supplementary angles exceeds the smaller by 18 degrees. Find them. So first of all, we are talking about supplementary angles. Supplementary angles are those angles which add up to 180 degrees. So two angles, if they add up to 180 degrees, we say that they're supplementary angles. So let the required angles be x and y. Now it is given to us in the question that the angles are supplementary. So we can say that x plus y is equal to 180 degrees. It's also given to us that the larger of the two supplementary angle exceeds the smaller by 18 degrees. This means the difference between these two angles is 18 degrees. So we are going to first mention that y is greater than x. You can also write x is greater than y. That's okay. Accordingly, you will frame the next equation. So the larger of the two supplementary angles, that means I'm talking about y here. The larger of the two supplementary angles exceeds the smaller by 18. So y minus x, the bigger one minus the smaller one is equal to 18. The difference between these two angles is 18. Let's name this as equation 1 and this as equation 2. Okay. Now we solve this by substitution method. So let's take the second equation. We can write this as y is equal to 18 plus x. X I have taken on the right hand side and I've got this as plus x. Now this value of y, I'm going to put it in the first equation. So put y is equal to 18 plus x in the first equation. So we'll get x plus 18 plus x equal to 180. I have replaced y here by 18 plus x. Now in the next step, we will get 2x plus 18 is equal to 180. We can take this on the other side. We will get 2x is equal to 180 minus 18. Then we will get here 2x is equal to 162. And then we will get x as how much? This would be 81. X is 81. Now x is 81. We'll now solve for the other one, that's y. It's already given to us that the larger of these supplementary angles, the larger of the two supplementary angles exceeds the smaller by 18. I have got the smaller one as 81. So the larger one would be 81 plus 18. That's very logical. If this doesn't strike you, that's okay. You can just go as usual. X is 81. Take this value of 81 and put it either in first, second or third equation. You will get the same result. So here I am putting this x equal to 81 here. So by third equation, we have y is equal to 18 plus x. So y is equal to 18 plus 81. So we can say y is 99. So thus the required angles we have 81 and 99. As we can see that the larger one is is exceeding the smaller one by 18 degrees. And also we can see the supplementary. They will add up to 180 degrees. So you can always just take your answers. You can check the conditions which are given to you in the question. Now, if the conditions are satisfied, that means your answer is correct. If they are not satisfying, that means you've made some mistake. So we can write the concluding statement. Thus, required angles are 81 degrees and 99 degrees. Okay, students, I hope you've all understood this question. Let's proceed. Let's discuss the next one. The coach of a cricket team buys 7 bats and 6 balls for 3,800 rupees. Later, she buys 3 bats and 5 balls for 1,750 rupees. Find the cost of each bat and each ball. The cost of each bat and each ball. So, we whatever is unknown to us, we are going to assume it to be X and Y. So, let the cost of one bat be rupees X and cost of one ball be rupees Y. Now, in the first case, the coach of the cricket team buys 7 bats and 6 balls. So, if one bat is costing X rupees, 7 bats would be costing 7X rupees. If one ball is costing, this is not 7, this is Y, unknown quantity Y. If one ball is costing Y rupees, 6 balls will cost 6Y rupees. In all, he is paying 3,800 rupees. So I'm adding in all. The coach of a cricket team buys 7 bats and 6 balls for 3,800 rupees. So this is the first equation which we have got. In the same way, in the second case, she buys 3 bats. So one bat is costing X rupees. So 3 bats will cost 3X rupees. One ball is costing Y rupees. So 5 balls will cost 5Y rupees. And in all, the coach is paying 1,750 rupees. Now, these are the 2 equations which we have got. Now, we'll solve them by substitution method. So, here I am taking the second equation. Let's say we take the second equation. I'm writing here Y in terms of X. So, 5Y equal to 1,750 minus 3X. I've taken this 3X on the other side. It has become minus 3X. Then in the next step, Y will go on the other side. So it will actually come in the denominator. So this is the third equation. Now I'll take this equation and I'm going to put this in the first one. So in the first equation, we have 7x plus 6y is equal to 3,800 rupees. That is 7x. 7x we'll write as it is. There's no change here. 7x plus 6 times of y. Y here is 1,750 minus 3x. 1,750 minus 3x over 5 is equal to 3,800 rupees. In the next step, we'll solve for the LCM. So LCM here is 5. I'll multiply throughout by 5. So 5 multiplied by 7x would be 35x. This would be 35x. If you multiply this by 5, this 5 will get cancelled. You will get 6 times of 1,750 minus 3x, and then in the end 3,800 multiplied by 5. So we'll work on these calculations first. 1,750 multiplied by 6, we'll get 0 here, then 0 here, and then 3 here we'll get, and then we will get a 42, 5, and then 4. So that's 10,500. And this 6 minus 3x will give us minus 18x. Now 3,800 times 5. Let's see how much is this. 3,800 times 5 will give us 0, 0, then 0 here, 4 here. This is going to give us 19,000. Now if we take these two, we'll get 17x. Now 10,500 I'm going to take on the other side. I will get 19,000 minus 10,500. And here I will get 7x is equal to 8,500. So finally here x is 8,500 over 17. That means x is 500. So x we had assumed as cost of one bat. So one bat is costing 500 rupees. I'll take this value of x equal to 500 and I'm going to put it in, let's say, the third equation. So the third equation I'm writing here, y is equal to 1,750 minus 3x over 5. I will put this 500 here. So let's see how much do we get. So we'll get here y is equal to 1750 minus 3 times of 500 over 5. Now this is actually 1750 minus 1500 over 5. Here from the numerator we will get 250. So that's 250 over 5. And here we will get y as how much? 50 rupees. So the cost of one bat is 500 rupees and the cost of one ball is 50 rupees. So this was asked in the question. Very simple. Okay, so now I hope you've all understood this, children. Let's discuss the next one. Oh. Wait a minute. So these are all the questions which are given from one of the exercises of NCERT, and this entire exercise is based on substitution method. In fact, before you come for the next class, please make sure that you do all these questions. These questions are already given to you in the textbook. Make sure that you do all these questions. You have to solve them and you have to make sure that you're able to do it on your own. Right now, I'm explaining you everything, but please make sure that you're able to do these questions independently. Now, we've already discussed this one. Okay. Now, this is the taxi charges question. You will get such questions in different forms in the reference books also. The taxi charges in a city consist of fixed charge together with the charge for distance covered. For a distance of 10 km, the charge paid is 105 rupees. And for a journey of 15 km, the charge paid is 155 rupees. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 km? So we have taxi charges. It's given to us that there is a fixed charge. First of all, if you sit in the taxi, you have to pay a fixed charge. Let's take the fixed charge as X rupees. So this is unknown. Now, whatever distance you cover, accordingly also you have to pay charges. So every kilometer you have to pay a specific charge. So per kilometer charge, let us say that we are paying Y rupees. Now in the first case, we are traveling 10 km. So if we are traveling 10 km, so for every kilometer we are paying Y rupees. That means we will pay 10 Y rupees for 10 kilometers. But also we have to pay fixed charge. So I'm going to add X to it. That's the fixed charge which I've taken. It is given to us in the question that for a distance of 10 km, the charge paid is 105 rupees. So that's equal to 105. The fixed charge of sitting in the taxi, and then for traveling every kilometer, we pay Y rupees. So for traveling 10 kilometers, we will pay 10 Y rupees. That's the first equation. In the same way, in the second equation, and in the second case, it's given to us that we are traveling 15 km. So we are paying 15 Y rupees. Y rupees for every kilometer. So 15 Y rupees for 15 kilometers. And X rupees, that's the fixed charge. So the total charges which we are paying in the second case is 155 rupees. That is the second equation. Now in first part of the question, we have been asked to solve for the fixed charges and the charge per kilometer. So we will solve this by substitution method. So we take the first equation and we will write X in terms of Y. So I am writing X as 105 minus 10Y. I am taking this on the other side and this will become minus. This value of X, let's name this as equation 3. This value of X, I am going to put this in the second equation. So I will actually get here 105 minus 10Y plus 15Y is equal to 155. X I have replaced by 105 minus 10Y. Then we have 105. We can combine these two. We will get 5Y here. That is 155. On the right hand side, we'll get 105. If I take on the other side, this will get subtracted. So we will get 5Y equal to 155 minus 105. This will give us 50. 5Y equal to 50. So finally, Y is 10. Y is 10 here. Now we've got Y as 10. That means 10 rupees is the charge for every kilometer. We'll take this value of 10 and we are going to put it here. Let's see what value of x we are getting. So x we have 105 minus 10y. We've got y as 10. So we will put it here. 10 times of 10. So that's actually 100. So x equal to 105 minus 100. So x is finally 5 rupees. So 5 rupees is the fixed charge and 10 rupees is charge per kilometer. So we have fixed charge here. That is 5 rupees. And per kilometer charge we have as 10 rupees. So this is the per kilometer charge. This is the fixed charge. Also, it is asked in the question, how much does a person have to pay for traveling a distance of 25 kilometers? So if a person is traveling for 25 kilometers, so he has to pay 5 rupees as the fixed charge. And then for every kilometer, the person is supposed to pay 10 rupees. So for 25 kilometers, he is going to pay 25 times of 10. So that's 5 plus 250. That is 255 rupees. That is the answer. That means that much amount he is going to pay for traveling 25 kilometers. I hope students this question is clear to you. Now let us do the last question here. That's related to fraction. Now for a fraction we know there is a numerator and there is a denominator. So a fraction becomes 9 upon 11 if 2 is added to both numerator and denominator. We don't know the numerator and denominator. Let's take the numerator to be x and the denominator as y. So the fraction will become x upon y. It's given to us in the question if we add 2 to both numerator and denominator. That means if we add 2 here and here, x plus 2 upon y plus 2, then the fraction will become 9 upon 11. That's the first equation which we have got. In the second case, it's given to us if 3 is added to both numerator and denominator, it becomes 5 upon 6. So we are taking this original fraction. We are adding 3 to the numerator and denominator. So this becomes 5 by 6. We have to find the fraction here. That means we need to solve the original y and x. Sorry, this is y. So we've taken in the original fraction numerator as x and the denominator as y. So the original fraction is x upon y. Now we are adding 2 to both numerator and denominator. So we've got x plus 2 upon y plus 2 as a new fraction, which is actually 9 by 11. This is given to us in the question. In the second case, we are adding 3 to the numerator and denominator. This is the new fraction. That is actually 5 by 6. This is also given to us in the question. Now we have to solve for the original fraction. That means we need to solve for x and y. So I'm going to first simplify these two equations. So I'll cross multiply here. So we'll get from the first equation as 11 times of x plus 2 is equal to 9 times of y plus 2. Let's simplify this. We will get here 11x plus 22 equal to 9y plus 18. This I'm going to take here. I will get 11x minus 9y. 22 I'm going to take on the right hand side. I will get 18 minus 22. That's actually minus 4. So instead of the first equation, I will now be using the third equation. In the same way, we will simplify this second equation. So we'll cross multiply here. So we will get from the second equation as 6 times of x plus 3 equal to 5 times of y plus 3. So we are going to now multiply this. 6x plus 18 is equal to 5y plus 15. 5y I'll take here. I'll get here 6x minus 5y. 18 I'm going to take here. I will get 15 minus 18. That is actually minus 3. So this is the fourth equation. So instead of first and the second equation, I'm going to make use of third and fourth now. We'll use the substitution method again. So I'm taking the third equation here and I'm writing x in terms of y. So I'll write here 11x equal to minus 4 plus 9y. And I can take this on the other side. Plus 9y I've got by taking this minus 9y on the right hand side. So from here we'll get x equal to minus 4 plus 9y over 11. This value of x I'm going to place here. So I'll get 6 times of minus 4 plus 9y over 11 minus 5y equal to minus 3. So we can see that the LCM here is 11. We'll multiply throughout by 11. We'll get 6 times of minus 4 plus 9y, and this will become minus 165y, and this will become minus 33. So multiplied this by 11. 11 in the numerator and denominator will get cancelled. 11 times of 5y, sorry, 11 times of 5y would be here 55. I've taken it 15 by mistake. Wait, sorry. So this is 11 times of 5y, that is 55. 55 y we have got. Wait a minute, let me check. So this is 6 times of, all right, 15, 3. Okay. Now, in the next step, I'm going to take this 6. I'll multiply this inside. I will get minus 24 plus 54y minus 55y equal to minus 33. From here, I'll take this minus 24 on the right hand side. This will become plus 24. So we will get here, and also we'll combine these two. We will get minus y equal to minus 33 plus 24 will give us how much? It is going to give us minus 9. So y here is 9. So y is 9. That means the denominator is 9. Now we've got the denominator as 9. We are going to take this 9 and we are going to put it here in the, let's put it here in the fourth equation. You can put it anywhere. Let's put it in the fourth equation. So we will get here 6x minus 5y equal to minus 3. That's the fourth equation. I am putting 9 here. So that's 5 into 9 equal to minus 3. We will get here 6x minus 45 is equal to minus 3. 45 I'm taking here. This will become positive 45. And then we'll have 6x is equal to 42. Finally, x is 7. 42 over 6, that's 7. So x we have got 7 and y we have got 9. So we have the original fraction as x upon y, that is actually 7 upon 9. So in the question we were asked to solve for the original fraction, that is 7 upon 9. Now you can always check here. If you put here 7 and 9, let's see. If you're adding 2 to this, you will get 9. If you're adding 2 to 9, you will get 11. So this condition is being satisfied. In the same way, if I take 7 and 9 here, in place of x, I'm writing 7 and 9 here. I'm just checking my answer. So 7 plus 3 will give me 10. 9 plus 3 will give me 12. So 10 upon 12 I am getting. If I simplify this, I will get 5 by 6. So like this, you can always check your answers. You can just take the values of x and y, put them in these equations, and you can check. Also, you can just read the question and you can make sure the conditions given in the questions, they are being satisfied. Okay, children, so I'm winding up here. We are going to meet again tomorrow and we are going to discuss elimination method. So we have discussed in detail substitution method. In tomorrow's class, we'll be discussing elimination method. And please make sure that you revise before you come for the next class.